Okay, so sequences are just lists of numbers that usually have a pattern. And so your goal is to identify the pattern. And so for number 1, our sequence is 3, 9, 15, 21. And so our pattern in this case is adding 6. Okay, and so we can get to the next term by adding 6, which would take us to 27. Add 6 would take us to 33. Add 6 again, we would get to 39. Okay, for number 2, the pattern 1, 3, 9, 27, 81. We're not adding the same number each time. We are multiplying the same number each time. Okay, and so we can get to the next number by multiplying by 3. So take that 81, multiply it by 3, we get 243. Times 3 again, we get 729. Times 3 again, we get 2,187. Okay, this next one, 200, 150, 25. It looks like we're dividing by 2, but we want to focus on multiplication rather than division. And so we could write this as times 1/2. The reason why is we have a way to represent repeated multiplication. We don't have a great way to represent repeated division. Okay, and so we can continue the pattern by continuing to multiply by 1/2. We'd get 12.5. 6.25. And then 3.125. Okay, and so for Algebra 1, the 2 types of sequences you are going to notice is going to be adding and multiplying. If your pattern is adding, it's called an arithmetic sequence. And in parentheses, I'm going to write subtracting, since that's just adding a negative number. If you are multiplying, it's called geometric. In parentheses, I'm going to put dividing, since that's just multiplication by a fraction. Okay, so adding goes with arithmetic. I remember that because they both start with A. Adding, arithmetic. Multiplying is geometric. I don't know why those are the names, but that's what we have. And so the goal is usually you want to be able to find either the next term or even some arbitrary term, like the nth term. Okay, and so the number that you are adding each time is called the common difference. It's called the difference because you can find it by subtracting the second and first term. Okay, they usually represent that with the letter D. If you're multiplying, they call that change a common ratio. And they usually represent that by R. Okay, and so when we are trying to find the 100th term, for example, on number 1, we could add 6, add 6, add 6. We'd be here a long time to try to find the 100th term. And so what we try to do is find a formula to help us do that. Okay, and so to find the 100th term, we could start with the first term, which is 3. And to get to the second term, I would add 6. And to get to the third term, I would add 6 again. To get to the fourth term, I would add 6 a third time. And then if I keep going, If I add 6 99 times, that will get me the 100th term. Okay, and so repeated addition is multiplication. 3 plus 6 plus 6 plus 6 99 times is 3 plus 6 times 99. And that would be really easy for us to type into our calculator. 3 plus 6 99 times is 597. We can do something similar with the multiplication problems. We could start with the first term, which is 1. And to get to the second term, we would do times 3 for this problem. To get to the third term, we would times 3 again. Fourth term, times 3 a third time. And then if I keep doing this 99 more times, I would have the 100th term. Okay, and so of course we don't want to type times 3 99 times. So when you have repeated multiplication, that turns into a exponent. And so that would be 1 times 3 raised to the 99th power. Okay, and then when you type that into Desmos, that's actually a really, really large number. These grow very quickly with exponents. And so I'll just show you what that looks like. It's moving to scientific notation. That 1.7 times 10 to the 47th means we're moving that exponent, the decimal, to the right 47 times. That's a huge number. You're not going to get any numbers like that on a test. And so you can just write huge number. Okay, and then same thing for the next one. We start with our first term, which is 200, and we would multiply that by 1/2. I'm going to use parentheses for fraction. 99 times. And that would give us our 100th term. And so that's going to be a very, very tiny number. If I type that in, 200, if you cut that in half 99 times, it's going to be tiny. So this negative exponent in scientific notation means we're moving the decimal to the left 28 times. That's how many zeros we'd have before that 3. And so we'll just put tiny number. Okay, and so the main thing about sequences is the notation. It can look kind of scary. And so I'm going to write some terms up here. They use the letter N to represent the term number. And so for the 100th term, N would be 100. And so if you see a sub N, that just means it's the nth term. And you can kind of read that as any term. It's just a way to say some arbitrary term, any term. And so if you see a sub and -1, that's just their way of referencing the previous term. It's just notation, so we don't have to keep writing any term and previous term. Right? And so a sub 1 would be the first term. And then a2 would be the second term. I'm not going to write all that, but like a100 would be the 100th term. Okay? And so we have two ways we can represent sequences. One is the recursive form, which isn't that useful. It really just gives you the pattern. And so it says, I'm going to write it in words first, then the symbols. You can get to any term by taking the previous term and adding that common difference D. And so using our notation, any term equals the previous term plus the common difference. And so in the case of number 1, any term equals the previous term plus 6. For geometric sequences, any term equals the common ratio times the previous term. Okay, so using our symbols, any term equals the common ratio times the previous term. And so for number 2, any term equals 3 times the previous term. And then here we'd have any term equals 1/2 times the previous term. This isn't really a useful formula because if you're trying to find the 100th term, you would have to know the 99th term, which you probably won't know. All it really does is tell you what the pattern is. If you saw this notation, you would know your pattern is adding 6. If you saw this notation, you would know you're multiplying by 3, you're multiplying by 1/2. That's all it's really useful for, is to see what your pattern is. Okay, and so the useful formula is the explicit formula, and that's actually what we used. And so now I'm going to put the notation on there. Okay, and so the formula we used to get to the 100th term is we took that first term, that's where that 3 came from, and we added the 6, which was our common difference, n minus 1 times. So to get to the 100th term, we did it 99 spots over. Okay, and so you can get to any term by starting at the first term, adding the common difference, n minus 1 times. For the common ratio, or for the geometric sequence, it's similar. To get to the 100th term, we started at the first term, and we multiplied the common ratio, n minus 1 times. And so any term equals the first term times the common ratio, n minus 1 times. So this n minus 1 is up in the exponent. The n minus 1 for arithmetic is not up in the exponent. So be careful. Don't try to mix the two. There's no exponents for arithmetic, only geometric. Okay, so let's look at some applications. And so for these first examples, we just want to identify the pattern, the type of sequence. And so number 1, 5, 15, 45, 135. That's multiplying by 3 each time. And so we would consider this a geometric sequence since it's multiplying. And because it's geometric, we have a common ratio, and that common ratio is 3. And so the recursive notation says you can get to any term by multiplying 3 by the previous term. Okay, so that's just recognizing the pattern, recognizing it's a common ratio, and putting it in the recursive formula. The explicit formula is the useful one. It says you can get to any term by taking the first term, which in this case is 5. Okay, so we're going to take that first term and we're going to multiply it by 3 n minus 1 times. The 5 was the first term. The 3 was the common ratio. So to get to the 8th term, we would take that 5 and we would multiply it by 3 7 times. That 3 is the common ratio. That 5 is the first term. And to get to the 8th term, we have to do n minus 1 for the exponent. And so we could type that into the calculator. 5 times 3 raised to the 7th would give us 10,935. Okay, this next example, we go from 1,000 to 500 to 250. That's multiplying by 1/2. So once again, this is geometric. We still have a common ratio for geometric sequences, and this time it's 1/2. So any term for our recursive formula is 1/2 times the previous term. Okay, the recursive formula just gives you the pattern. We recognize it was multiplying by 1/2, so it's a common ratio, and it appears in those 3 places. The explicit formula says you can get to any term by taking the first term, which we have, 1,000. We're going to take that 1,000 and we're going to multiply it by 1/2 n minus 1 times. 1,000 is the first term. 1/2 is the common ratio. And so to get to a 60, we would take that 1,000, multiply it by 1/2, 59 times. That's going to end up being a really tiny number in the calculator. Okay, and so that 1/2 was the common ratio. That 1,000 was our first term. And to get to any term, the nth term, you multiply it n minus 1 times. Okay, this next pattern, 8, 12, 16, 20, it is adding 4 each time. And so our sequence is arithmetic. Adding is arithmetic. And now we call it a common difference, which in this case is 4. And so our recursive formula says any term equals the previous term plus 4. Okay, plus 4 is our pattern. So we have a common difference this time, and then our recursive formula has that plus 4 in it. The explicit formula is the useful formula because it starts with the first term. Take the first term, which is 8, and we're going to add 4 to it, n minus 1 times. That n minus 1 is not in the exponent, so be very careful. It's got to be the same size as the 4. Okay, and so for the 45th term, we would take the 8 and we would add 4 to it 44 times. That 4 is the common difference. That first term was 8, and then the 44 comes from 1 less than the term we want. It's always n minus 1. And so we could type that in. Some of you can do it in your head. 8 plus 4 times 40, 184. Right, and then for the last one, 36 to 30 to 24 to 18, we are subtracting 6 each time. So this is still considered arithmetic. We're just adding a negative number. And so our common difference, to signify that we are subtracting instead of adding, it's a negative. And so our recursive formula says you can get to any term by taking the previous term and subtracting 6. Make sure your minus 6 is bigger than the n minus 1. That's a subscript. Subscripts, exponents, got to make sure they're neat. Okay, and then our explicit formula, the one that actually helps us, is you can get to any term by taking the first term, which is 36, and subtracting 6 and minus 1 times. 36 is the first term, minus 6 was our common difference. Okay, and so to get to the 9th term, we would take 36, we would subtract 6 8 times. (36) minus 6 times 8 is negative 12. Don't need a calculator for that, but better to be safe than sorry. Right? And so that 36 and then minus 6 got a color code. And so one other thing I want to talk about with arithmetic sequences, they sometimes simplify the explicit formula by distributing and combining like terms. So if you don't see this as your answer, they may have just distributed to get 4n minus 4, and then combine the 8 and the negative 4 to get positive 4. And so that would be the simplified form. Okay, this is only for arithmetic. And so like on this one, they would distribute the negative 6. Be careful with distributing the negative 6. You get negative 6n plus 6 because we're multiplying by a negative. And then that 36 plus 6 would be 42. Okay. Another way they represent this explicit formula is rather than putting this D in front, they may put it at the end. Either one, it would be equivalent. Right, so some other ways they ask these questions is just giving you information rather than the sequence, which I think makes it easier because you don't have to identify the pattern. Here they're telling me the first term is 4, and they're using the word ratio for the 2, and so that means multiply. Ratio is for multiplying. And so we would start with the 4, and we would multiply by that 2, and to get to the 5th term, we would multiply it 4 times. So the 2 is the common ratio, 4 is the first term, and to get to the 5th term, n minus 1 would be the exponent. I think that's 64. It is. Okay, and then for this last one, they're saying A1 is 100. That means first term. They're saying D, which is common difference, which means add. So our first term is 100. Our common difference, which means add, is 4. And so we're going to start with the 100. We're going to add 4 to get to the third term. We're going to do it twice. You can do plus 4, just 4 times 2. And that would get you the 108. Oops. Common difference was 4. First term was 100. To get to the third term, we do it twice.